Welcome back. So today we're going to be working on 5.4 with our isosceles and equilateral triangles. This is on page 224 in your notebook. So you should have this green foldable. So we're going to start out with some vocabulary. So we'll just go ahead and flip up this first page. So some vocabulary terms there. First, an isosceles triangle. So what is an isosceles triangle? Well, that means that we have exactly two congruent sides. And we have talked about isosceles triangles before. I'm going to go ahead and mark our congruent sides here. And we know from what we talked about before that these base angles or these bottom angles here also have to be congruent if those sides are congruent. Okay? An equilateral triangle has exactly three congruent sides. Okay, so we're going to go ahead and mark those as well. So those are all congruent sides. So then what does that mean? Again, just like over here, if we have the sides being congruent, then the angle opposite of those sides must be congruent. So on an equilateral, same thing. The side opposite of those equal sides have to be congruent, so that means we have three congruent angles as well. Some more vocabulary here. We're going to move on down to our isosceles triangle that we have here, and we are going to identify some angles and some sides. So the first one that we're going to look at is this top angle up here. That's called a vertex angle. Okay, and a vertex angle is the angle formed by the legs. The angle formed by the legs. Now the other angles that we have, so we've got one here and one over here. Those are our base angles. Okay, those are our base angles, and base angles are the angles adjacent to the base. Okay, so those are the two angles that are adjacent to the base. Okay, so then we're going to move on to some sides. So let's just start with this bottom side here. So that side, that is called our base. And that's the third side of a triangle, or an isosceles triangle to be more specific. Now, most of the time, the base is the one that it's sitting on. So like this is sitting up and this is the bottom. However, sometimes it could be sitting like this, and these two are congruent to each other. This is still my base. Okay, so don't just think because a triangle isn't sitting on the base that the base changes there. Because these other two sides are called something different. So these two sides, these are our legs. So the two congruent sides of an isosceles triangle. Okay, so it's the two congruent sides of our isosceles triangle. All right. Okay, so let's keep moving. Okay, so for this next part, we're going to be looking at our base angle theorem. So the base angle theorem says if two sides of a triangle are congruent, then the angles opposite of them are congruent. And we just talked about that on the other side. So that's going to help us to be able to find our x and y. So what that tells us is since these two sides are congruent to each other, that these two angles must also be congruent to each other. So we can set up an equation that says 7x plus 2 equals 8x minus 7. Because if these angles are congruent to each other, then these two expressions have to be equal to each other. So now we're just going to solve for x. So I'm going to subtract 7x from both sides and add 7 to both sides. So we end up with 9 on the left and x on the right. Okay? So then we need to find our y. Well, in order to find y, we're going to have to plug x back into these and figure out what size of angles that we have. So 7 times 9 is going to be 63 plus 2, so we get 65. And just to check and make sure that I found my correct x, I'm going to plug 9 in to the right side as well. 8 times 9 is 72, minus our 7 also gives us 65. So we know we did those angles correctly. So now we know that every triangle adds up to 180. So we can take 65 plus 65 plus 2y, and that's going to equal 180. So we get 130 plus 2y equals 180. Subtract our 130. We end up with 2y equals 50. Divide by 2, and we get y equals 25. Okay? All right, so let's keep moving then. So for number 2, sorry about that, give me 1 second to focus that in a little bit. So for number 2, we're doing the same thing. We have two congruent sides, so that means these angles down here must also be congruent. So I can say 2x plus 4 equals 4x minus 22. Now I'm going to solve for x. So I'm going to subtract 2x from both sides. I'm going to add my 22 to both sides. So then I end up with 26 equals 2x. Divide by my 2. I get x equals 13. Now for y, same thing. I need to plug my x in to figure out the size of those angles. So 13 times 2 is 26 plus 4. This ends up being 30 degrees. The other side, I have 4 times 13, which should be 52, minus 22 is also 30. So I know I have those angles done correctly. So 30 and 30 plus my 4y is 180. So we're going to take 180. This is a different way of doing it from what we did here. 180 minus 60 equals my 4y. So then I can say 120 equals 4y. Divide by 4. And I get y equals 30. Okay. All right, so that's those two. So now we're going to move on to the converse of the base angle theorem. And if you remember, the converse means we're flipping the if and the then. So originally we talked about two sides, then we knew the angles. Now we're starting with the angles, which if we know the angles are congruent, then we can say the two sides. So we flipped the if and the then. All right, so moving on to number 3. So since we have these two angles being congruent, then we know that these two sides have to be congruent. So we can say 5x plus 7 equals 42. So I'm going to solve for x, subtract my 7. 5x equals 35. Divide by 5 on both sides, and we get x equals 7. Same thing for number 4. We have two angles being congruent. The sides opposite of those angles must also be congruent then. So this 20, that's extra information that we don't really need for this problem. We're going to say 8x plus 19 equals 12x plus 3 and solve for x. So I'm going to subtract 8x from both sides. And I'm going to subtract 3 from both sides. So I end up with 16 equals 4x, divide by my 4, and I get x equals 4. I would encourage you to leave the x or the y on whatever side you have it on. Like up here I have 30 equals y, down here I have 4 equals x, instead of like this one is x equals 7. Leave it on the side that you have it on. That's just good practice, because when we start doing proofs, if you flip it, because that's what you're in the habit of doing, then you're going to end up making mistakes on your proofs. Because if you remember, to be able to flip this to the other side is one of our properties that we had. Okay, so just leave it there. It's just good habit. All right, so looking on the next page, we're going to be looking at some of our base angle theorems. So we have a corollary to our base angle theorem. So it says if a triangle is equilateral, then it is equiangular. And we talked about that a little bit ago. We said if the sides are congruent, then the angles have to be congruent. Well, if we know the angles are congruent, then the sides have to be congruent. So those are the two corollaries that we have here. One of them is dealing with if we know the sides, then we know the angles. The other one says if we know the angles, then we know the sides. Okay, so looking at number 5, this one gives us the sides, so then we know the angles are congruent. So then if I know all of those angles are congruent and every triangle adds up to 180, each one of these has to be 60 degrees. Each one of them has to be 60 degrees. Okay, that's with every equilateral triangle, every one of them. So now I can set up my equations. 5x plus 25 equals 60 and solve. So I'm going to subtract 25. So I get 5x equals 35. Divide by 5, and I get x equals 7. Same thing for y. For y, I have 4y equals 60. Divide by 4, I get y equals 15. And then the last one is z. 32z minus 4 equals 60. Keep in mind, I put that slash through the z just so that I don't mix it up with my 2's. So then I'm going to add 4 to both sides. So I get 32z equals 64. Divide by 32. And I get z equals 2. Okay. All right, so then on number 6, this one is dealing with the angles. If we know that the angles are all congruent, then we can say the sides are congruent. So that means these sides all have to be congruent to each other. So then I can set this up and solve for my x, which is 6x plus 16 equals my 9x minus 11. So I'm going to subtract 6x from both sides. I'm going to add 11 to both sides. So I end up with 27 equals 3x. Divide by 3, and we get x equals 9. Okay, now it didn't ask for 9 on this one. This time it says find the perimeter of the triangle. Well, to find the perimeter, I need to know each of the sides. So I'm going to have to plug this back into these. 6 times 9 is 54, plus my 16. So I end up with a side length of 70. And that's centimeters. I'm going to check my work. So 9 times 9 is 81, minus 11 also gives me 70. So I know I've done my math correctly there to find the sides. If these two sides are 70, then this one must also be 70 centimeters. Perimeter is the distance around the outside, so I have to add up all of my sides. So you can either take 70 plus 70 plus 70 to get your perimeter, or you can take 70 times 3 to get your perimeter. Either one of those will work. So then we end up with a perimeter of 210 centimeters. 210 centimeters. Okay, all right, that is all that I have for you today. This one goes in your notebook. This should be on page 224 in your notebook. So then you're going to be doing the practice problems that go along with this. Those practice problems should be following this page, page 225, 226, and 227. So 225, 226, and 227 are your practice problems that go along with this. All right, that's all I have for you today. Have a great day, and I'll see you in class.